Good morning. My name is Subham Kundu, and this is my first project from Lamentics, which is on the topic Flipkart. And the project summary is this. This project focuses on analyzing customer support data to understand the key factor influencing customer satisfaction, CSAT, and overall service performance. The primary objective was to identify patterns in customer complaint and examine how different variables such as complaint subcategory, support channel, agent tenure, and customer location impact satisfaction level. The dataset was cleaned and processed using Python handle inconsistencies, removed unnecessary space in column names, and managed missing values before conducting the analysis. Exploratory data analysis was performed using pandas and matplotlib to uncover trends and relationships within the data. Various visualization, including bar graphs, bar charts, histogram, and density plots, area plots, were used to examine the complaint distribution and customer satisfaction score pattern. The analysis revealed that certain complaint categories, particularly order-related and return-related issues, contributed significantly to the overall complaint volume and had a noticeable effect on customer satisfaction scores. This project demonstrates practical skill in data cleaning, statistical reasoning, data visualization, and business insight generation by identifying the major drivers of dissatisfaction and highlighting areas that require operational improvement. The analysis provide actionable recommendations to enhance customer experience and organize support performance. The problem statement of this project is customer support team handle large volume of complaint, but organization often lack insight into the factor affecting customer satisfaction. This project aims to analyze the complaints and the service data to identify key drivers of customer satisfaction and develop machine learning models to predict customer satisfaction levels, enabling proactive decision making and service improvement. These are the general guidelines of this project. And first of all, we have to import all the important libraries such as pandas, numpy, matplotlib, seaborn, etc. Then I'm reading the CSV. Then I'm seeing that few heads, like few 5 rows of the dataset, and from there I saw that there were a lot of missing values in the dataset. So I have to first handle them, which I will be doing later in this project. And then I just saw the number of rows and columns, from which I saw that there were 20 columns and somewhere around 85,907, almost 86,000 rows. So these were name of all the columns that were used here. And I'm writing this df.info command to see the data type of each and every column, and how many null values they have, or they have null values or not. Now here I'm checking for duplicate values and count and duplicate values in each and every rows, and from which we saw that there were no duplicates in unique ID, which is quite good. And then I'm seeing for the missing values, from which I saw that a lot of columns were having missing values, so I have to handle them. Then I just did a simple bar plot to see which column has maximum number of missing values, from which I saw that connected handling time is a column which has maximum number of missing values. Then I'm again printing the number, the column names, and then I'm describing the dataset here. And after going through each and every column, I understood that these were actually what every column depicts. For example, I'm reading a few of them, like unique ID is used to uniquely distinguish every customer interaction record. Order ID uniquely identifier for related order. Not all support tickets may have an associated order, like survey response date, date when customer submitted their satisfaction survey, and like manager overseeing the support team, etc. Like this, and there were 20 columns, so 20 of them were described here, what each of them depicts. Then then I run this command for checking the unique values, from which I saw that every unique ID, which is supposed to be the primary key, has every unique ID, which is quite good. So no value in unique ID is repeating. Now I have to make the data set ready for analysis, for which I have to do remove the duplicates, like in the data type of the columns, which is a float or integer. Then I have to replace the missing values in them with the median, and in case of any object type column, if there is a missing values, then I am replacing them with unknown, so which will reduce the number of missing values in the dataset and will make it much easier for analysis. So I have performed all of them as it has been shown here. Then I'm seeing again for the top 5 rows of the dataset, and I can see that the unnecessary things that were missing were replaced, and the missing values in integer type or float type data columns were replaced by their medians. Then here is the first plot, which shows the distribution of customer satisfaction scores by number of customer, from which we can see that a lot of customers were satisfied and they have given us a rating of 5. Like 2 rating were the lowest and 1 rating. So a lot of people were also not satisfied by the products or the services provided. Then the second plot is customer distribution score by category, like which category, like return related issues were highest. From this plot, we can easily understand that the maximum issue which has been raised were regarding the returns. Then the third plot also shows same thing, complaint category by number of complaints. Again, from this dataset, we can see that return related issues were the highest. And then uh, then the fourth plot shows the channel versus the number of complaint, which means that through which channel the maximum complaint were raised, and that is through inbound. Then this plot shows average CSAT score. This line plot shows average CSAT score by uh, channel name. Then this box plot here shows the CSAT score distribution by agent shift. Then here is a scatter plot which shows connected handling time versus customer satisfaction score. Then here is a area plot which shows CSAT score trends by category over time. uh, we have various things like cancellation feedback and order related returns, others, etc. were shown according to the dates. And here is again the CSAT code distribution by top issue, from which we can clearly understand that return is the most or return is the highest issue faced by the company or the customer, shows the return as the maximum issues. Then here are the 3 hypothesis testing, like does complaint category affect customer satisfaction scores? Does agent experience impact customer satisfaction? Does support channel impact customer satisfaction, etc. like that. And here are the 3 machine learning models which I have implemented, and I have explained all of them. So the let's go to one by one. Let's go through them one by one. The first model is like it predicts the CSAT score. In this, this is a simple linear regression model which was implemented to predict customer satisfaction score based on relevant features such as handling time and item price. Linear regression was chosen as the initial problem because it is simple, interpretable, and effective for understanding linear relationship between independent variables and a continuous target variable. The dataset was divided. CSAT score was set as the target variable here, and according to which the machine learning is predicting, going through all the others, such as all other columns, such as item price, connected handling time, and it is predicting some CSAT values. And we can see that pretty much all of them were above 4.2, which is quite a good rating. Like above 4, it is quite a good rating. Which hyperparameter optimization technique has been used here and why? In current implementation, no hyperparameter optimization technique was applied because the model uses simple linear regression which does not have a major hyperparameter that require Turing like tree-based or assemble model. Linear regression mainly learn coefficient directly from data using ordinary least square methods since it does not involve parameters like tree depth, number of estimators or learning rate hyperparameter. Tuning is generally not necessary for this algorithm here. Then the second model, what this model shows, this model predict like in this implementation, the random forest classifier was developed to predict customer satisfaction score as a customer classification problem. Instead of predicting a continuous value, the model predicts CSAT rating category. The top goal of the model is to determine how various operational and customer related feature influence customer satisfaction level. The target variable selected in CSAT score and multiple feature were used including support channel, complaint category, subcategory, customer city, product category, item price, handling time, agent Turing and agent shift. The feature represent both categorical and numerical information related to customer support interaction. Since machine learning model cannot directly process categorical text, random forest algorithm to process data correctly. The dataset was split into training and testing set using 80-20 split. I did not use 75-25 here, I used 80-20. Satisfied sampling was applied to ensure the distribution of CSAT classes remaining balanced in both training and testing. This helps to prevent biased model evaluation. A random forest classifier with 100 decisions was used. The classification weight balance parameter was included to handle any class imbalance in CSAT rating, ensuring minority classes are not ignored during training. Random forest works by building multiple decision trees on random subset of data and combining their prediction to produce final result. Then here is the third model. What does this model predict or why I use this model? In this model, the model is predicting the support ticket category for each customer interaction. Specifically, the target variable in is category. Here, I'm picking the target variable as category, and on basis of them, the full model is trained. Uh, So in this model, the model is predicting the support ticket category for each customer interaction. Specifically, the target variable is category, which means the model learns pattern from features such as name, customer, city, product category, item price, handling time, agent details, tenure bucket shift, and CSAT score to determine the type of issue that belongs to after training. When new customer support data is given, the XGBoost classifier analyzes the combination of this input to predict the most likely category depending on the dataset. In simple terms, this model automates the classification and the customer supports ticket so that the Instead of manually identifying the issue, the system can stagnantly assign the correct category based on historical pattern from the data. What final conclusion we reached to this project? This project focuses on building a machine learning solution to improve customer support operation by predicting the key outcomes from historical interaction data. After understanding the business objective, the dataset was cleaned and preprocessed by handling missing values, converting numerical fields properly, and encoding categorical variable to make them suitable for modeling. Exploratory analysis helped in understanding feature distribution and their relevance to business performance. A structured trend split with classification ensured fair evaluation across categories. Multiple models were explored, and an XGBoost classifier was implemented due to the strong performance of structured data and ability capture complex relationship. The model was trained to predict support ticket categories based on customer detail, product information, agent attributes, handling time, and CSAT score. The evaluation metrics such as accuracy, prediction, recall, and F1 score were used to assess performance and interpret the model's business impact. The final outcome demonstrates how machine learning can automate ticket classification, reduce manual effort, and improve routing efficiency and support faster resolution times, ultimately enhancing customer satisfaction and operational effectiveness. Thank you for giving me this wonderful opportunity to describe about my project. Hope this project finds you well.